Okay, I'm back. There was some serious technical difficulties. My ImageMate froze. Anywho, we're back with number 6. Last problem, if you're still with me. Okay, maybe you gave up. So this has to do with this is a review of lesson 1 with that fixed perimeter, right? The fixed fencing of like a garden. So here are some lengths and widths of an area of a garden whose perimeter is 40 feet. So you have this fixed perimeter. The perimeter is not changing from 40 feet. But as we know, as we adjust the dimensions, staying at 40 feet, if you adjust the dimensions, the area shifts, even though the perimeter doesn't. So we're going to complete the table. So we know that if it has a fixed perimeter of 40 feet, right, we know all 4 sides have to total up to 40. So another way to think about it is if you just take the length and the width by itself, one length and one width, it has to equal half of 40. So I know that length and width, these two together have to equal 20. That's one way to think about it. And there's lots of ways to add up 2 numbers to make 20. 14 and 6, 8 and 12, 10 and 10. 12, hey, that's the same as this one, just flip. 12 and 8, 14 and 6, 16 and 4. And I thought about these adding up to 20 because that would be half of the rectangle, and we just duplicate that over here for the other width and length. Okay. All of these would keep a fixed perimeter of 40. Okay. Interesting that all of these have the same perimeter, but their areas would not, maybe some of them would be the same, but a lot of them would be different. So I could just take a calculator and say area you get by multiplying the length and the width. 96 for 8 by 12. So arranging the rectangular fencing this way or your garden this way gives you a larger area than this way. How about a 10 by 10? Yeah, that gives you 100 square feet. Now when you make the length larger, then all of a sudden you flip it around and the width is now 8, which just like this one, just looking at it differently, back to an area of 96. How about a 14 by 6? Hey, we did that one up there. No, we didn't. I'm sorry, dyslexia. 84. But a 16 by 4 is the same as a 4 by 16. All right. We completed it. Yay. These were, right, length and width. All the different lengths and widths that keep a fixed perimeter of 40, and then there is the resulting areas. So what lengths and widths do you think will produce the largest possible area? If it looks here, it looks, when lengths and widths are equal to each other, it looks like that is maximizing the area. Okay. So as length was getting bigger, you could be like, oh, length is getting bigger, so is the area. But then look, after a certain point, it gets smaller again. So when they are equal to each other, you have maximized the area. Okay. When length and width are the same, so basically in this case, a square, area is maximized. All right. Good times. All right. Talk to you later. Bye.